Because this chapter, which we have already done in our class, I'm just repeating it again because most of the students were absent in the class. This is about protection and security. All of us know that the main focus in our operating system is that we should secure our system. And what are the different procedures to make it protect and make it secure? First of all, the purpose of protection system is to prevent any accidental or intentional misuse of the system. Like in multi-programming system, the protection is required with different resources which are being shared or if you are using it idly. In both cases, you need protection and security. In modern protection concept increase the reliability of the complex system which makes use of shared resources. In that case, organizations are also helping and different softwares are there to implement the protection. Like in your computers, you are having antivirus system. In our labs, we are having the protection which is maintained by the domains. So different protection securities we are implementing to make it our system as protected. Then we are following different policies. In these policies, proxy settings also apply. If we are not applying proxy settings, we are having different kind of checks to determine that which kind of security measures we have implemented in our systems. So different kind of mechanisms and policies are defined for it. I'm just repeating because already we have done in the class. So for protection mechanism, what are the resources which we want to authenticate? We need file protection. For example, if I am making one file, I need that file to be secure while I'm sharing with anybody or if I'm not sharing with anybody. But whether if I'm working in the shared environment or I'm not working in the shared environment, I need my file as a protected file. Then I need the memory as a protected. Whatever I'm saving in my memory, I need the protection of my memory and security policy that reflects an organization's strategy to authorize access to the computer resources. So some security policy should be defined there for any organization. In that for security policy, what you will say that this organization will define some kind of rules or methods that how they are going to authorize computer resources. In authorizing, we mean that managers have access to personal files or operating system processes have access to the page table or whatever. So these all policies are defined by the organization when they are determining any kind of setup or mission goal of their organization. Then we have different goals of protection. In domains of protection, that what is the domain or area till where the protection is required. In that case, operating system consists of collection of objects, which is your hardware and software. And hardware, you know which things are included in software, you know which things are included. Each object, you know, it is having unique name and it is accessed by the different kind of set operations. So different kind of set operations which can be possible or implemented in the objects are CPU. Sometimes it is only executed. Sometimes tape drivers can be read, write, and rewound. Memory can be read and write. CD-ROM only read operation can be performed. Different kind of operations are there. So for each operation, the domain is specific. For example, for CPU, what is the domain of the CPU? For tape driver, what is the domain of the tape driver? Similarly, for memory, till which area memory can be accessed. This is shown by the diagram that these are the objects. This is the protection state for it, the state transition, then rules and policy. All of them together, they are determining your sub-objects. So domain structure that operating processes operates within a protection domain. For example, when I am saying that this CPU is having protection, it means till which area CPU is having access right or CPU is having the authorized access. So that is the domain or area where the CPU can implement any of that protection strategy. Domain is a set of access rights. Operations on an object amount to application of functions that may perform the state of the object. The specific subset of functions that can be meaningful apply to an individual object or it is specific to some object, particular object, not to complete object. So that depends that you want to target a one particular object, you want to target the complete objects within that system. In that case, we are saying that no process is allowed to apply a function which is inappropriate to a given object type. In that case, we can't apply any function which is not appropriate for an object. For example, if we have defined any object that it can't access the right operation So we can't give that right operation to that object also. It will perform only the operation which is in excess to that object. The second thing is that each process is permitted to apply only those functions that is explicitly authorized for a specific object. Like means that you can change the domain, or you can change the rights of that object. For example, if I'm making one file as my read only file, and when I'm changing the settings of that file, and I'm going to do work on that file, being the owner of that file, so it means explicitly I have made changes in my file. So this is all your domain, that what is the domain and which kind of access rights is having. Protection domain is a collection of access rights, each of which is a pair of object identifier, and which kind of rights or which kind of policies or strategies it is having for applying the protection. Domain need not be static. Domain may overlap, domain may change, domain may have overlapping different domains. In overlapping different domains means one object is having access to the second object in that overlapping domain. So different domains are working there. Like for domain D1, the example is given. Object 1 can read and write, object 2 can execute, object 3 can read and write. Similarly, for different objects, it is mentioned that which kind of operations they can perform, and the same thing is being mentioned with the help of the diagram. Where is your overlapping domain? This area, O4, is your overlapping, which is the overlapping area of your domain 2 and domain 3, which is your print area. So print object function is performed by domain 2 also, domain 3 also, for the object 2, object 1, object 3. So in domains, you are having users, you are having processes, and you are having procedures. You know what is a user, what are the processes, which kind of processes are working, and which kind of procedures they are implementing. Now, domain example in the Unix. In Unix operating system, domain is related with a user only. You know who is managing all input-output devices? Our kernel is responsible for the all input-output devices. So we are saying the kernel associates to user ID with the process. In that case, user ID, unique ID given to each process. Now, it is independent of process ID of the real user ID and the effective user ID or set UID. This is different from that. The ID which is being given by the kernel associate with the two user IDs for a process that is different from the real user ID and your effective user ID. The real user ID identifies the user who is responsible for the running that process. Effective user ID is used to assign ownership of newly created file, to check file access permissions, or we are checking the rights, which kind of rights are available, or we are checking that which kind of signals it can send, or which kind of interrupts it can generate, and we are checking it via till system call. So an owner identification and a domain bit are associated with each file. Already you know that each file will have the owner identification and domain bit. This bit identifying that which kind of file or operation is going to be saved on that file. So a setuid program is an executable file. Why executable file? Because each time you are running that file. That's why you want it as executable file. So in that executable file, you are having the set UID bit, and in set UID bit, it is setting the permission mode field. Permission mode, that which kind of permission rights it is having. What are the other methods? Other methods are used to change domain in operating system in which user IDs are used for domain definition, because all systems need to provide such a mechanism. So in that case, you are giving some rights to change some kind of domain or change some kind of function within some domain for some object or some processes. This method is suitable only when a privileged facility needs to be made available to the general user population. For example, printer, for example, scanner, or you are accessing any common hard drive. So in that case, you are making some sharing between within your network. In that case, you can access, you can change the domain rights within one domain of the object. The domain switch is accomplished via file system. What is the domain switch? Switch change of the domain. If any one object want to change the domain, that is done by the file systems. And you know file systems, FAT32, NTFS, all these are your file systems. In that case, each file has a set UID flag. When set UID flag is set, current user ID is set to the file owner of the program being executed and reset when it is on exit. So this is all about your domain. What is basic concept of the domain? I discussed with you that domain is not complete without your access right. Now, what is your access right? I had told you that the rights or permissions which any object is having. The excess rights we are going to conclude in our excess matrix. Excess matrix is used to implement a protection. Now, what is excess matrix? Matrix, mathematical matrix. Excess matrix, you are having one table which kind of excess rights are available for any object. So excess matrix is implemented in various ways. Domain is represented by rows of excess matrix. Object is represented by column of excess matrix. Each entry in the matrix consists of set of excess rights. So all four corners you are having different kind of excess rights where you are representing your object, which kind of object, which kind of right it will perform, which kind of permission levels it is having within your domain or outside your domain, which kind of rights we are giving to the object. So for most collection of subjects and objects, the matrix will be sparse, or since most objects will be accessible only by a few objects, and most subjects will be accessed only a few objects. I will show you with the help of the diagram. For example, this is your domain. Domain D1, what is the function? Read operation. In domain 2, no function 2, function 3 is your read. This read, execute is your what? These are your access rights. And this is the matrix. Different domain in different domain for different objects, which kind of matrix you are performing. For example, the process in domain D1 can read files F1 and F3. The process in domain 2 can only use printer. Process in domain 3 can read file F1 and execute file 3. So with the domain, this access matrix, quickly you can define me that D3, which kind of access rights available to it. D4, what it can perform. So quickly you will tell me in D4 that it can read the files F1 and it can write the file F1. It can read and write operation on the file F3. Quickly you can inform which printer is available for the which domain. Printer is available for the D2. So process in the domain 2, they can only use a printer. The other thing can't use a printer. Already I discussed with you the domain switching, different kind of mechanism or policy which is applicable on the domain, different kind of objects, blank entries which are indicating no access right. A process is switched from one domain to another domain when executing the switch operation. For example, if I want to print for an object which is one process which is in domain 4, I can switch from D4 to D2 and then I can perform the print operation. The switching is also applicable with the help of the file systems. Each entry in the access matrix is modified individually or notified individually. Domain switches, if possible, if only if access rights switch, like from I to J, different bits are being switched. This is your domain structure with the help of the objects. Different same thing that here in domain 1, domain 2, domain 3, different files, printer, then again for domain 1, domain 2, domain 3, domain 4, we are saying domain 1 can switch to domain 2 only. The processes in domain 1 or the objects in domain 1 can switch to domain 2, not in the domain 3, not in the domain 4, not in the domain 1. So here with the help of access matrix with domain as object, quickly you can determine the switching between the domains also. Column-oriented list is called access control list (ACL). Unix uses access control list for the file protection.